Hey, all. Today we're going to continue talking about measures of variation and how spread out our data sets are. And we're going to add on to the measures that we've talked about of range and variance and standard deviation. So the first one we will talk about is the coefficient of variation. A lot of times we want to be able to compare two different data sets, and that becomes a little challenging if those data sets have two different types of units. It's hard to directly compare two groups of data if their units aren't exactly the same. So, for example, if we're comparing two groups' heights, we can compare them pretty easily if they both have heights in feet and inches. But if we are trying to compare heights in feet and meters, that might be a little more challenging because they're not direct comparisons. We would either have to um, recalculate one of the groups, or we can use this thing called the coefficient of variation. It's going to utilize the standard deviation that we have calculated already and the mean. So for samples, we use the S standard deviation and the X bar mean. If we have a population data set, we can use sigma and mu. Those are for populations. Typically, we have standard deviation and mean from a sample data set. So we did in our lesson last time calculate measures of spread variation, and we did some measures of center a couple lessons ago for this data set over here. I think that had to do with power plants. And so we can calculate the coefficient of variation by taking our standard deviation, and we can just type in equals here. And if we already have the standard deviation, we can click that cell. We want to divide it by our mean. We can click that cell. And then I'm going to put those in parentheses. Oops. Because then I need to multiply that by 100. Let me make that bigger. If ever you don't see a decimal that I have, you're going to want to adjust your column width. So I'm taking my standard deviation that I've already calculated, dividing it by my mean, and then I'm multiplying that by 100. And so I want to compare it to this data set. I believe this was teacher salaries. This is the teacher salaries in South Carolina. And so I can do the same thing. I can take my standard deviation, and I'll start with parentheses, divide it by my mean, and then multiply by 100. And so now we would be able to compare which groups are more variable. You can see that the coefficient of variation for our salaries is much different than our power plants. That's probably not the best comparison because they're two completely different things. But we had these data sets on hand with the calculations already done, so I figured I would use them. It would make more sense to compare maybe the salaries of teachers in South Carolina to maybe the salaries of doctors in South Carolina or some other industry. We might want to compare the number. I believe these are nuclear power plants to maybe some other country and the population of those power plants. But for today, being able to calculate those measures is what we are looking to do. We can also estimate the standard deviation. The standard deviation is a bit of a tricky calculation if we wanted to do that by hand. Excel helps us, or other technology helps us calculate those values. But if we wanted to do a quick estimate of what the standard deviation is, we could use this rule where we can approximate it, not exactly, but we can approximate it using the range and dividing it by 4. A word of caution is that we should only use this when we have a histogram or a distribution that is approximately symmetric and unimodal. So, and this is going to be a very bad drawing because I'm using my mouse, something like that. But we can do that for these two data sets. We're going to take our range. So I can say equals, I'm going to take my range and then divide it by 4. And you can see it's less than our standard deviation. And that might be true because this might not be a symmetric data set. I know that this data set over here was not symmetric. We said it was skewed to the right, but let's calculate the range estimate just to see what happens. So we first need to calculate the range. That is our biggest number in G12 minus our smallest number in G1. And then we can use that, take our range and divide it by 4 to estimate our standard deviation. You can see it's much different. It's off by about 2,000 from our standard deviation. Because this was a skewed data set and our standard deviation takes every data point into account, that means this estimate is not going to be as accurate of an estimate, and we probably would want to avoid using it when talking about the standard deviation. We did in our measures of central tendency lesson, we were able to calculate a mean when we had group data. What I mean by group data is that we have them in these frequency tables that we've been building to create histograms. If we don't have all the individual data points in order to calculate mean or standard deviation, we can do that by using our group data. If you remember, what we did was we took our classes and then we found the midpoints. To find the means, we multiplied the midpoint by the frequency and then found the average from that column. So we can, here I have those frequencies and midpoints. We can take the frequency times, and we're going to use X to represent our midpoint. We're going to multiply them together. So I can hit equals my frequency times my midpoint. And then I can actually grab that little corner there where you can see that little green square. And once I get the crosshairs show up, I can drag it down and it's going to multiply all of my frequencies times all of my midpoints. Or I can just do the multiplications myself, whichever one works for you. I'm also going to take my frequencies and multiplying by my midpoint squared. So we have this formula here for how to calculate the standard deviation based on a grouped data set. It's pretty complicated looking, but if we use our technology, the calculations become a little bit simpler. We're going to take n, our sample size, or our number of data points, multiply it by our frequency times our midpoint squared, which we're going to go calculate. Subtract from that our frequency times our midpoints all squared. So let's first calculate this column. I'm going to take, say, equals my frequency times, and then I'm going to just do my midpoint. I don't know if that will work. Yep, it worked. We should get some pretty big numbers. I'm going to check just to make sure my numbers are right by doing an alternate method. I'm going to do my frequency times my midpoint times my midpoint, because squared is really just a number multiplied by itself. So another way to do it, let me delete that out for now. Before you move on, if you do have trouble finding these values, please do ask me before you go and move on so you can have some confidence doing it yourself. So now we're going to find the sum of both of these columns. And so I can just equal sum, and you can see that the that Excel knows what I want it to do, but it didn't work for me. There we go. Excel knows what we want it to do. So if I click equal sum, it's going to ask me if I want to add up those values from D2 to D8. I do. And now I'm going to use my formula here and these two values to make my calculation for standard deviation. So far I have multiplied my frequency times my midpoint, and then my frequency times my midpoint squared, and I've found the sum of these two columns. So my calculation tells me to take my total number of values. So I have 5, 9, 14. Here I can do this. If I highlight those, it's going to come down here. It's going to tell me the sum. So I have 20 data points. So I am going to do 20 times f times x squared. That's this value. And you can do this in multiple steps if you want to. That might make it easier. I'm going to subtract from that this value squared. So this is the top of my fraction over here. I'm going to divide that by 20 times 19. So I'll just say equals this number divided by 20 times 19, because 20 is the number of data points. N minus 1 is 20 minus 1. And that's going to give me an estimate for the standard deviation for this grouped data set. So again, what I did was I multiplied my frequencies times my midpoints. I multiplied my frequencies times my midpoints squared. For both of these columns, I found the sum. That means what we'd get when we add them all together. And I did the little algorithm, but you could also just highlight them and find the sum down here. It'll say sum. I can find the sum down here as well. We use those two values, and I will type my sum in here. And 20, which was our number of data points, to just plug into this formula. And this gave us, this gave us the variance, and we're going to find the standard deviation by doing the square root. Where's my, there it is, SQRT. We're going to do the square root of the variance. So there's our standard deviation. So this is variance. This is standard deviation. I'll abbreviate. If any of that is fuzzy for you, I can totally understand. This is a lot compared to the other calculations we've made. So please do ask before you move on. So if you've got your questions answered, I do want you to try this one. I want you to calculate these values by putting this data into Excel and using our tool. Pause, do this on your own, and then press play, and I will have the answers for you. Please do try it on your own. If you make a mistake, that's totally fine. You can always ask me for help while you're working. So pause now. So hopefully you paused, you tried this on your own, and you gave it a shot to calculate these measures of variation. If you got one or more of them wrong, please do ask, and we can figure out what went wrong. Maybe you typed a data point in wrong. That's usually the case. But if you didn't get any one or more of them right, please do ask me, and we will figure out the error. If you feel confident, I want you to go on. We have some practice attached to this lesson today where a question box will pop up and you need to put your answer in that question box. You need to answer all the questions to complete the video. If while you're working through these, you need a little bit of help, you can ask a neighbor, you can ask a friend, you can ask me for help. I would rather you learn how to do this correctly, um, even if that means me helping you through one of the problems. So please do take your time on these, ask for help when you need it, and good luck.